Okay, welcome back. So we were just looking at the triangle and giving all of the congruent angles and the proportions of the corresponding sides. This is going to be the exact same thing. In fact, if you want to consider this like a try problem, I think that would be a great idea. Okay, so now is a great time to pause and then unpause in a second. All right, welcome back, right? So here's what we have here. We have N, P, Q, R, U, V, S, T. So that means that I need, without even looking honestly at this picture, I can say N and U are congruent angles, P and V, and so on. Okay, so angle N is congruent to angle U. Angle P is congruent to angle V. Angle Q and S. And then my last one is angle R and T. So those are my congruent angles that it asks me to list, and then it wants the proportions of the corresponding sides. So we don't have any side lengths here, but we do have the corresponding sides just like we did in the triangle example. So we would put we get RQ over TS, R and T are corresponding. RQ over TS has to be equal to RN over TU. And then we have NP over UV, PQ over VS. Okay, so the proportions, the ratios of those need to be proportional. That's actually all for this problem. So we call it good, all right? So example 2, I copied this from last year. So I thought it was cute. This is a word problem that I personalized. Kyle wants to use the rectangular photo shown for the background of his computer's desktop, but he needs to resize it. Determine whether the following rectangular images are similar. If so, write the similarity statement and scale factor. Explain your reasoning. All right, so we, of course, have the ability to work backwards once we know the definition of similar figures. So I want to figure out, are all of these similar or not? So I have 14 by 12, 12 by 15, and 8 by 10. The nice thing about this is, I'm going to say, let's look at the sides like this first. That seems to be the same side in all of these, because it's literally that side of the picture. And something that's worth noticing is that I highlighted the rectangular images part, and that's because it says 12 inches on this side. That means it's 12 inches on that side too. So we actually only need to check these two sides to determine whether or not something is, like, whether or not these are similar. And I'll let you in on something. I already can tell that if I have a 12 and a 12 and then a 14 and a 15, those are not going to be proportional, because 12 over 12, well, that's like 1. So I'm saying 12 over 12 has to be equal to something. So 12 over 12 is 1. This is comparing A and B. And then I want to check and see if it is the same for 14 over 15. Which, of course, it's not. It's going to simplify to 14 over 15. So A and B are not similar to each other. Okay. A and B are not similar to each other, but there's still some hope for C being similar to one of those. So let's compare I don't know, B and C. So we're going to be going about this the same way. We've got our 12 and our 8 that need to have a ratio. So 12 over 8, well, it's not ideal, but we could simplify this. But either way, technically we don't need to worry too much about the simplifying part because I can just set this up like a set of two ratios, like you did in your IXL, and I can go from there and check it. So 12 over 8 is supposed to be equal to 15 over 10. Okay, so you had multiple methods that you used to determine if two ratios were proportional. I personally like to simplify down to the lowest possible terms. So actually this is divide by 5, and I get 3 over 2. And then here if I divide by 4 and divide by 4, that's not how you write division, but you would get 3 over 2 as well. So that means that these are in fact proportional ratios. So this equals 3 over 2. And this equals 3 over 2. So yes, these are proportional. So B and C are similar. I'm going to just write that as I think I can just use the statement like image A is similar to image B. But let's write it out the long way anyway, just in case. JKLM is similar to ABCD. And the benefit of doing that instead of just saying like, oh, option B and option C are similar is that we get to see what those corresponding parts would be, okay? So that is how you check for that similarity, okay? The other thing, remember, is that we for polygons to be similar, we need to have congruent angles. I forgot to mention it, but those rectangular images, how it says rectangular, that kind of solves that problem for us and says, hey, it's not really an issue. Okay, so since all of the angles in a rectangle are the same, and they're all rectangles, we know that the angles would have to be congruent. So we're just worried about the sides for this one. All right, one last thing about this one. When I compared A and B and they weren't similar, and then I compared B and C and they were similar, can I conclude that A and C wouldn't be similar? And the answer is yes. You don't need to worry about that one because if B and C are similar but B didn't match A, C is not going to match A. Okay? And the last thing is if they asked us for a scale factor, it would be 3 over 2. Right?